Hey guys, welcome to my channel, and today I'm recording 5070 October November 2021 paper. This is part 3 of this paper. I've already solved part 1 and part 2, and you can find it in the link below. I have made the playlist and I've dropped the link in the description box below. You can check it out. I've also solved May-June 2021. You can check that out too, as well as 2018, 19, 20. I've solved all of them. So you can check it out. I have put the links in the description below. So I've already solved section A, question number 1, 2, 3, and 4. Today we're going to start with question number 5. Alright, so without any further ado, let's start the question. Question number 5 says lithium reacts with aqueous zinc iodide. Explain by referring to the equation why this reaction involves both oxidation and reduction. The question is mainly saying it shows us a reaction, that is lithium and zinc iodide reaction, and then the question asks us that why is it being oxidized and reduced both. So for it, first of all, we need to understand what is being reduced and what is being oxidized. If we see over here, so lithium is being oxidized because it loses electron. Alright, however, if we see zinc is being reduced since it gains electrons. So this is what we're supposed to write, that in this way both oxidation and reduction is involved. Moving on to part B, acidified aqueous silver nitrate is added to aqueous zinc iodide. State the observations made. If we add acidified silver nitrate in zinc iodide, so the observation will always be yellow precipitate. Alright, so make sure that you need to learn all these. You also learn the colors of different elements of periodic table and few reaction colors. All of these you need to make sure that you learn it, or you must have performed it in your labs, so make sure to remember it. Moving on to part C1, when aqueous bromine reacts with aqueous zinc iodide in a brown solution is formed. Name the products of this reaction. So here we are basically talking about the reaction with aqueous bromine and zinc iodide. So over here we have bromine plus zinc iodide. We will have, our reaction will be zinc bromide will be formed and iodine will be formed. Okay. If we look at it, it's basically halogen reaction. This part is mainly related to halogen reaction, in which on the basis of reactivity, displacement takes place. So this is how you're going to solve it. It's a pretty simple question. Moving on to part 2, explain why aqueous. Also, for example, if over here rather than bromine we had acetylene, so zinc acetate wouldn't be formed. Alright, so make sure you also know this thing, that what will react and what will cause no reaction. Alright, so this is how it will be done. Moving on to part 2, explain why aqueous bromine does not react with aqueous zinc chloride. Okay, the same kind of question just came over here. Over here, chlorine is more reactive than bromine, that is why the reaction will not take place. Likewise, as I gave you the example of acetylene, it will also have the same reason. Alright, so moving on to question number 6. Phosphorus reacts with hydrogen to produce phosphine, pH3. 2p plus 3h2 is equals to 2pH3. The reaction is endothermic. Part A says complete the energy profile diagram for this reaction, label reactants, products, and the enthalpy change. Okay, so for this, if we see, if we look over here, this is basically an endothermic reaction, and this is the type of energy profile diagram that is usually made. This is reactants. Make sure to label it. I haven't labeled it, doesn't mean you guys won't label it. It's very important to label it, since it's asking for complete energy profile diagram. So you need to write over here reactant, and over here you need to write product. So if we see, the energy of reactant is way lesser than product. Since it's endothermic, it is going to absorb energy, and enthalpy change will be between reactant and product. Alright, pretty simple question, and I'm sure you guys have already practiced this several times. So it will be on your fingertips. Moving on to part B, explain in terms of bond breaking and bond forming why the reaction is endothermic. The reaction is endothermic because bond breaking is endothermic, and however bond making is exothermic. That means more bonds are broken than made, or we can say more energy is released. Sorry, more energy is absorbed than it is released. Okay, in both the ways it is correct. Moving on to part C, phosphine reacts with oxygen to form phosphorus 5 oxide, P4O10 and water. Complete the equation for this reaction. So we have this complete equation given with us, however it's not balanced. We need to make sure to write the numbers that will make it balanced. So it's pretty much basic and simple. We have 4P, so it can be 4PH3 and then plus O2. So now we have 4P and we have 10, and this is also variable. So if we see, we have 3H over here and 2H over here. So it should be something around, if we balance it, it can be 6 over here and 10, 6, 8 oxygens. Alright, so basically there is no hard and fast rule related to balancing. Balancing is more of a trial and error method. However, with practice you will be able to understand the tricks of how to solve, how to balance an equation. Alright, so it will become very simple for you all. Alright, so that is it for this paper. I'll be uploading more papers really soon. Make sure to like, share, subscribe and comment if you have any difficulty. And yeah, that's it for the video. Thank you so much for watching and best of luck for your exams.